In this lab, management wants us to create an SD-WAN central network controller. Specifically, management wants us to connect our network to an SD-WAN network controller so we can use the web browser to monitor the network, apply policies, and update configurations to the network. What is SD-WAN? SD-WAN stands for Software Defined Wide Area Network. SD-WAN helps companies connect offices and locations using software-based control and centralized management. How does SD-WAN work? SD-WAN software allows multiple types of internet links, such as local internet like cable, digital subscriber line broadband, cellular LTE connections, traditional multi-protocol layer switching, or MPLS, or private links, and allows them all to be combined. SD-WAN devices at each location bring these links together in a unified overlay network. The physical connectivity like MPLS, Internet, LTE, they're all separate under the SD-WAN. But the SD-WAN controller provides a unified virtual view and configuration model for simplicity. The separate links appear as one consolidated network with pooled resources. This simplifies management compared to individually configuring each link. Without SD-WAN, links are individual silos without visibility into one another. Events and metrics that can affect the performance of the network, such as bandwidth usage, latency, which is delay, jitter, which is just a variation in delay, and packet loss at one location, are not analyzed as part of the overall WAN environment. But with SD-WAN, events and metrics that can affect the performance of the network, such as bandwidth usage, latency, jitter, and packet loss at one location, are analyzed as part of the overall WAN environment through the software. The centralized controller uses this visibility to optimize globally based on local data. This is important because the performance of the network is influenced by the combination of these conditions, not just one condition alone. For example, a network might have high bandwidth and low latency, but if there's a lot of jitter or packet loss across links, the quality of service could still be poor overall. The central monitoring allows the software to automatically route traffic across the best links based on rules or policies you set up about how your network should be handled. If a link degrades or fails, traffic is dynamically switched to another available link. So this provides fast failover. SD-WAN simplifies connections and improves performance between offices by pooling multiple link types into one virtual network, intelligently managing traffic flows over the links, adapting quickly to changes using software control, adding new links or sites without new hardware installations, and lower costs compared to legacy WAN approaches. Traditional WAN uses fixed private hardware links like MPLS between sites. It's constrained by the hardware capabilities. SD-WAN, though, is software defined and combines links like the Internet and LTE. It is flexible and agile since the software is the one that controls the network. Now that we understand the benefits of SD-WAN, let's set up the SD-WAN network controller for our network by first connecting the SD-WAN router to the switch. Now, before we configure it, let's take a quick look at PC 1 through 4 and make sure all of their DHCP IPs are working correctly. If the DHCP fails, try setting it back to static and then DHCP again to see if it kicks off the DHCP offers to make it work. Now, let's configure the SD-WAN network controller. First, we'll go to the Config tab to enter the name of the server and the default gateway of 192.168.30.1, which is the interface on router 1, which is connected to this network. Then we'll go to the Gigabit Ethernet 0 interface of the SD-WAN to enter the IP address and subnet mask based on what management told us, which was 192.168.30.4 and 255.255.255.0. Now, let's use any of our PCs to connect to the SD-WAN web portal by typing in the IP address of the network controller as an HTTP website URL in the browser. Then we need to create our new user account for the web portal. Then log into the SD-WAN with the account you just created. Then click the hamburger button on the left-hand side to open a menu, and click Provisioning. We need to configure the network controller credentials from the Credentials tab with the SSH credentials that are already in use on our existing network devices. What this will do is enable the network controller to establish SSH connections with our network devices. The SSH username is admin and the password is Cisco123, and the enable password is Cisco321. Management wants us to name the description for the SSH credentials as My Device's Credential. Now that we have the credentials needed to connect to the network devices, we can go to the Discovery tab and use our admin SSH credentials to discover the other network devices. Then we need to add the discovery type, which we currently have as CDP or Cisco Discovery Protocol. The name of our discovery, which management asked us to call My Network Discovery, and the IP address of the closest router, which is 192.168.30.1. Then the SD-WAN will crawl through your network devices with the SSH credentials to get the information on all the network devices. Once it's done, you can check the network devices if found in the Network Device tab. If you click on one of the configuration buttons next to a network device, you'll be able to see the details of that device. Pause and take a look around the network device configurations. Next, if we go to the hamburger menu and click Assurance, we can see the health of the router, hosts, like PCs and servers, as well as switches. You can also click the Hosts tab to see the host devices and what network devices they are connected to, along with the interface they are connected to. You can also click the configuration buttons here to see the configurations of the host devices. Under the Topology tab, we can see the unified network topology of network devices using SD-WAN. If you go to the dashboard on the hamburger menu, you can see more overall statistics of the network. Click the hamburger menu and go to the policy to see the quality of service policies the SD-WAN network has, as well as the scope, which are the devices the policy applies to. Since there are no QoS policies or quality of service policies, let's create one, starting with the scope. Management asked us to name the scope syslog_scope. Once we create the scope, we need to hit the configuration button to choose what we want to include in the scope. Management wants us to include all the current network devices, so let's choose them from the drop-down menu to include all of them. Then we can click Apply. Once you hit Apply, you can see all the devices now associated with the scope we created. And then let's add the policy. Management wants the name to be syslog_policy. The policy type is business relevant, which is for applications that are likely to be important for business operations, for example, Microsoft Teams software. The other options for relevance include business irrelevant, which is for applications that are unlikely to be important for business operations, for example, gaming software. And then the other option is default, which is for applications where no determination of relevance to business operations has been made. The protocol here is syslog, and the scope is the syslog_scope that we created. Then go to network settings and fill in the syslog IP, which is 192.168.30.5. Then click Save. And then click Push Config to send a new configuration to the network devices. Now, let's check R1 to see if the syslog configuration was pushed by the SD-WAN. Notice the logging 192.168.30.5, That means it took the configuration. Do a shut, no shut on interface loopback 0 just to get some logs going. Then check the syslog server to see if it grabbed the logs. Awesome. Let's do one more thing on the Cisco SD-WAN in the Assurance Hamburger menu item. Go to Path Trace. Click Path and use PC1's IP address as the source, which may be different for you due to the DHCP dynamically assigning the IP, and use R3's loopback 0 as the destination. Then click Play to test out the trace route path between the two. This will show you the trace route of the PDUs from PC1 to the R3 loopback interface, along with which in or ingress and out or egress interface is used on each device. Fantastic! You set up your first SD-WAN device. As you'll notice, once you get your network admin job, networking is getting closer and closer to software-defined networking with Microsoft Azure networking configurations, SD-WAN, and Amazon Web Services. No matter which platform, the networking concepts are still the same. You can learn whatever the platform is on the job or before your job interviews when you find out which platforms that company uses. But in the meantime, focus on the different concepts and frameworks I'm teaching you. Now, save the Packet Tracer Lab and update your notes. And then create your narrative. After that, share the Google Drive folder you have for this lab with the anyone with a link can organize, add, and edit access. Then submit the lab for review. If you don't know how to submit the lab for a review, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.